Hey everyone, my name's Taylor. I will be going over how Yugabyte Aeon can help simplify your cloud deployments, as well as offering you a ton of flexibility in how you go about deploying your databases. So yeah, a little bit about me. I'm a principal pre-sales engineer here. Been here for about 3.5, 4 years. Helped customers large and small from commercial to enterprise adopt, migrate, and move over to Yugabyte. So just a quick clicking on kind of what we do. We are a distributed Postgres system that really where the bread and butter of what we do is working on resilience. And what we want to do is help with those critical applications. So we have that built-in resilience, the seamless scalability, so you can scale endlessly, and the flexible geo-distribution that allows you to kind of deploy your applications and your database over multiple different regions. So a lot of time people always ask me, like, what is the value? What is the value that we bring to your as far as the database technology? And I kind of break it up into 6 different ways. So first is kind of our multi-model development. This really helps developers who may be coming from Postgres or Cassandra adopt our technology. Secondly, and you've heard it time and time again, is the ability to achieve strong consistency and resiliency. We also have the ability to have that unparalleled throughput. You saw Jake mention it about how much they're able to scale billions of operations a day. Karthik also touched about one of our customers that's doing 1 million operations per second with their current cluster. We also have the ability to distribute across the world, whether it be you need to do just within the US or you want to go across the entire globe. We can distribute your data for you without you having to worry about the sharding up of the data. We also have the ability to streamline the database cluster management. As we continue to grow, and especially with your developers, you don't want to spend the time working on how to actually run the database. You want to focus on the application and building up the application. So we help in making that more of a streamlined approach. And finally, we also talked about the data migration. We do have the Voyager tool, which really simplifies migrating your database from Postgres or Oracle over to Yugabyte. So I'm going to kind of get into these a little bit more in detail. So first is talking about how we do the kind of help with the developer productivity. So you have 2 different layers here as far as our database. You have the pluggable query layer and the distributed transactional layer. So start on the pluggable query layer. Really what we did for the Cassandra API is we took the Cassandra API and put it on top of the transactional database store. It's pretty similar to how you already run with Cassandra if you're familiar with it, but we added in a bunch of extra things that makes it even better than a normal vanilla Cassandra. So things like secondary indexes, JSON-B support, you get added benefits by moving to Yugabyte from your original Cassandra workload. And second, we had the Postgres API. And again, for this, really what we did is we ripped out the upper half of that query layer for Postgres and put it on top of the transactional storage layer. So anyone who's been working with Postgres, it feels exactly the same. I mean, even when you get into the command line, it says Postgres. It feels exactly the same. So that way your developers don't have to relearn a different technology like something like Spanner, where there's a lot of semantics that are new and you have to, it's proprietary. You get to use a lot of the same things you've already been using with Postgres. So that's kind of the upper layer. The second layer, that's really where the meat of everything is being done. So you have the idea of automatic tablet sharding. So what we do is, right when a table gets written in, we're going to break that table up into X number of pieces and then replicate that based on what we call a replication factor. So in order to get that high resilience, by default, we like to do about 3, right? So I have 3 shards of the data, which allows you to use any one piece of the data without falling over. And what we do is we completely take care of that for you. So when you write the table, initially, we'll break it up in those pieces, and then as you continue to have your data grow, we'll automatically shard it up more and more for you. You don't want all your data on a single tablet that grows infinitely. You want to make sure you break that up over time so that your load evenly distributes throughout all your nodes. So second, we do the load balancing as well. So with load balancing, you want to make sure that as you add more nodes, the load's getting distributed equally to each one of them. So as we add the shards, we add the more nodes, we'll make sure that all of the connections, all of the work is going to be evenly distributed through all of your nodes, so that way they're being used properly. You don't have one node doing all the work and the other 2 not really doing anything. Lastly, we have the distributed transactions, and then really how we do all of this is with RAF consensus. And really the idea of RAF consensus is when you do that replication of the data, they're going to form the 3 pieces of the data are going to form a little group, and they're going to elect a leader. And now that leader is actually in charge of writes and reads. So because of the in charge of the writes and the reads, that's actually how we're able to stay ACID compliant. So instead of something like Cassandra, where you have kind of anyone can take it if they're in charge of the data, and so at that time you can kind of the eventual consistency, with us, it's always highly consistent data. And when you talk about where we can deploy, we want to make sure you can deploy it wherever you're at. Whether it be AWS, Google Cloud, or Microsoft Azure, we support any one of those 3. We also support Kubernetes. So we have 2 different functions, whether it be a Helm chart or an operator. Again, wherever you want us to be, we'll be there for you. We also support an on-prem deployment. So if you have your own data centers and you'd like to run there, we can be there as well. So how do we stay resilient? So we talked about the replication factor in Raft Group, and that's a big piece of how we're able to stay so consistent and how we're able to stay up and resilient the entire time. So we have the 3 different deployment options, which are kind of more common ones that we see. I'd say the most common one that I see is number 1, which is where you have a single region with multiple zones. Now, each one of these, where you see those dotted lines, is kind of what we consider the failure zones. So in the first one, our failure zones is at the zone level. So at any one time, we can lose one of those availability zones. And the way we do that is by when we replicate that data, we guarantee one copy of the data in each one of those zones. So if you lose one, you're still going to be able to have 2 zones up. So if that happens, and say you lose a little bit of consensus, you still have the majority of them to come together, re-elect a leader, and continue. So people always ask me, what does that mean as far as downtime, or if I have a downtime flight transaction? That's where Karthik talked about the RTO of 3 seconds. It's just the missed heartbeats. So it's 3 missed heartbeats before they say, hey, we recognize that there's a problem here. Let's elect a new leader, up and running. Secondly, we have, just the other 2 is this multi-cloud, single cloud. About the cluster, say, within the continental US, latencies aren't too bad. But if you try to stretch something over across the entire world, if we're trying to stay consistent, latencies start to fall. So, we're not going to break physics here. So we do have other deployment topologies to go over, but this is one that we normally see for, say, just across the United States. You want to have the resiliency to lose any one region and still function. Lastly, we have what we call the multi-cloud, multi-region. This is not too much of a common pattern, but it's something we get asked about a lot is, hey, I want to run in AWS, Azure, and GCP. It's a great idea. A lot of time you have to worry about networking. It can be pretty slow when you're trying to go between those 2 clouds and also very expensive. So when we kind of really dig into it, the normal patterns we see is when they have maybe 2 data centers that are on-prem and they want to have 1 more in the cloud. It's a very common pattern we see with this. It's kind of that multi-cloud and multi-region. And again, at any one of those times in the multi-cloud multi-region, the entire cloud, the entire data center can go down, and you'll still be functioning. So in a real world, right, how does this actually happen? Well, we've seen it happen a few times. I'm not sure how many people are familiar. There was a very large snowstorm, ice storm that hit Texas a few years back, and it pretty much knocked out the entire state. Unfortunately, one of our customers, that happened to be one of their main data centers in Azure. Fortunately for them, for the databases, they were running on Yugabyte. When the data center went down, pretty much all traffic stopped, right? And at that point, the data started immediately. The leaders themselves started getting re-elected in the other two regions, and that it only being down for about 3 seconds. So for them, when we were trying to actually reach out to them, they were pretty much not answering us for a bit, and I got access to, hey, appreciate the calls. You guys were running a lot of other things. So it was great to see that data run for them, and they weren't answering our calls. It was great to see that in a real world application, we see that when the entire region goes down. So next we'll talk about a little bit about the geo-distribution and different models. And really, this is a lot of time where the flexibility. So we talked about kind of a single region with a multi-region, but just a single cluster. This is actually 2 separate clusters that are asynchronously sending the data across. Karthik did touch on this, but going into a little bit more detail, right? Really what this is we have one region on, say, East Coast, one region on West Coast. At any one time, you can use that entire cluster. And the other cluster, you can flip your traffic over and continue to run. Now, once that other cluster comes back up, we automatically do that data back up by using what we call write-ahead logs, which is what are actually syncing across the 2 clusters. So when the cluster goes down, we store those write-ahead logs for a certain period of time, which is configured, and eventually, once the cluster comes back up, we'll sync those back across. This is a really common pattern for people who have 2 data centers, which is a common but they want to have the consistency and the 8K to survive an entire data center outage. Next, and this is one that I'm actually really excited about, and I see asking about it pretty much every time I talk to them when I talk about multi-region, which is, okay, I'm expanding my data across the board, but I don't want to deal with the latencies that go along with it. I also have to worry about compliances when it comes to personal. So what we offer as well is synchronous replication. So this is actually just one cluster with 3 separate regions. We're putting the data directly to those regions. So what this means is if a user comes in and says, hey, in the US, I will write into the database, and as part of the key, that user will have a value, a column that's called geo, called US. When that happens, the US column will force the data to be located in the US, and all 3 copies will be located there. So in this case, a lot of times we see is in each one of these regions, you just multi-AZ. It could be multi-region, but normally multi-AZ. So that you have the AZ level fault tolerance of your data itself when they enter. And it's really, really great for hearing devices, as well as getting very low latencies to your users. Moving on from there, read replicas. A lot of databases have a lot of that's how they do their resiliency is they have an active and a hot standby ready to fail over should never happen. But with us, one of the unique things about our read replicas, we're actually write. You can write to our read replicas, and what actually happens is that they will forward the write along to the main cluster. And the reason it's able to do that is because our read replicas are actually part of the RAF group. You can actually collect leaders, but since they're part of that RAF group, they have a lot more information about the cluster, so they know who is the leader of that data, and I can forward my write along to. So it makes it a lot easier. You don't want to split up the reads or your writes. Or you can't do that in some cases. You can actually, say, hey, replica, I'll get good reads. My write latencies might not be as good if we're going across the board. It does have to go all the way across. But at the same time, you're not going to be constrained by not being able to write to those read replicas. So this is just a quick graphic of like all the different things that we, all the different options and kind of the pros and cons of each. And really at the end of the day, that's where a lot of what I do is helping out customers figure out what are the needs and what are the wants. There's sometimes you just can't break physics. If people say I can give you a multi-region clustering, give you low latency, data, highly resilient, I mean, we know that that's just not possible to do right now because you have to respect the physics of the network that you're working on. So if you got, we definitely love having conversations about how we can help go through all this to show you what the right approach is for you. So talking about scale, you already saw that from how their scaling their workload. But additionally, we've done some testing, TCC benchmarking. We get to a massive amount of scale. Additionally, one of our customers, GM, who you've already heard about, you'll probably hear more about them. They're able to reach up to second on a second. We know originally running roughly about 300 to 400 transactions per second, but that was running on a 250 node cluster. We were able to bring them down to around a 50 node cluster running 3 million TPS per second, while being able to keep up with their application. So we are able to pack more data on the nodes and also increase the transaction rate per node, making it a lot easier for them from a deployment point of view. So one of the other things, monitoring challenges with microservices. It's really hard to manage sometimes just all the databases, all the different applications that you're currently and so what we do is we automatically start doing this with the product. We'll give you a nice UI to look at, see all the different metrics. We collect hundreds of metrics and all the different things to help you really understand what's going on with your database. You can actually export these metrics. So customers that say, hey, I don't want to have to go there. Like, I don't even want to. I want to be able to just send these metrics to where I already have them. So you can do that. We just use Prometheus under the hood, plug in directly, start sending your metrics wherever you like. We also have the ability to have things like slow query view, slow query logger, and slow query monitoring. So we can capture those slow running queries. You hear it all the time, going from single node Postgres, as Jake mentioned, to a distributed system, there are some nuances there. There are things you have to rethink about how you're going to create data model and how you're going to do your queries. Because if you try to do things just regular, like how you used to in Postgres, you might run into some challenges about how efficiently those perform. So what we do is we have this monitoring slow query logger to actually capture those, and then you can come with us, or you can run it to analyze and understand how you can do it. We also have the performance advisor, which actually scans your cluster after it's been running and finds things like, hey, you have secondary indexes there. You want to read them. That way you don't have the extra disk that's being used up. And it'll also capture things like, hey, you want a hot shard or a hot node. Usually what happens is that you maybe have the data model quite correct. So you have a hot shard, that just getting slammed, and it's going to cause the rest of the cluster to slow down. So we also have a Terraform provider that makes using infrastructure a lot easier. Again, I've had customers that say, I do not want to look at a UI, I don't want to touch it, I want to do everything through CLI and export my metrics. And that's fair. It's definitely something that we see a lot, and what we provide you is a provider that will do all of the automation for your infrastructure for you. We have this for both both parts of our Aeon product, which is we only have in our cloud and in your cloud. You can use Terraform in order to manage your infrastructure automatically with the product. And lastly, we have value, that migration tool that was. I always recommend people to look at just schema into tool and it out. Let's see what changes. It's always important to do that to understand. There's always risk migrations. Running it through here will really help to understand what are those risks, how much of a lift and shift is this actually going to be. All right, so now what I'm going to talk about is kind of our different flavors of, and I 2.5 different flavors of our product. So first and foremost, one of the things I love about this company is our commitment to open source. There have been some changes out in the market with some other people where they have actually rolled back some of their commitment to the open source. But something that I really love about our founders is that they continue to say, no, we will always be open source. So everything that I talked about with those database features that you saw, you're going to get the same exact features in open source. We don't hide anything behind an enterprise license. So if you want the multi-region, you want the read replicas, you want that X cluster, you can absolutely do this on our open source. The only thing we're going to help you with is, we get that monitoring, the Terraform. That's where we come in to help you run the database itself. So that's where Aeon comes in. It has all of the different things that you would want with enterprise SLAs, enhanced security, and we help you run the database itself. So here's kind of a breakdown of what it really looks like. So I'll start on the right. So open source, pretty self-explanatory, right? When you run that, infrastructure's on you, the cloud's in your data center, all the orchestration's gonna be on you to manage. We do have some operators and Helm charts, so if you're running Kubernetes, that do help. And we have a CLI tool, a CLI for the database, but overall, it's on you. You have to provision the infrastructure, you have to do the upgrades, the backups, that's all on you. Next, we have Yugabyte Aeon. So we have 2 different versions of it, which is why I was saying about 2.5, which is in our cloud and in your cloud. In your cloud, right, this is a lot of time where you need to have the data in your data center for whatever reason. And again, the infrastructure will be in your VPC, the data will be in yours, and then we'll help you manage it with our services. And lastly, we have in our cloud, right? And this is taking it one step further. This is where you just bring the data, we'll handle everything else. We have a 24/7 SRE team that their entire job is to make sure that the database continues to run. So when we're talking about, where does responsibility really lie, right? As you go left to right, you're gonna get more and more responsibility taken off your plate and onto us. So at first you could see with OSS, it's all on you. We'll give you the software, and good luck, run it. You have the community support, and you can always come to us, but again, it's all on you to run. Next, we have what we call the Aeon BYOC. That's bring your own cloud, and it's more a little bit shared, right? There's a little bit that you'll be running, a little bit that we'll be running. So you're gonna be in charge a little bit of the of networking and the infrastructure, which we help set that up for you, but a lot of it's gonna be on you to run and with our help set up. And then when you get all the way to the right, this is where we're taking on all of it. The only thing that you have to bring is the data. You're in charge of it. Everything else, we take charge of. But there are a couple things you'll see that's still highlighted. So security and access, you can absolutely bring your own key if you have your own encryption keys. And from a networking standpoint, we do VPC peering, so you'll have to peer up our 2 networks together. So how do you choose, right? That's a big question, right? Between those 2 options, what is the best option for you? Normally, I just always say start with Yugabyte Aeon on the left. If you don't want to have to run your own infrastructure, it's a lot easier for us to run it. But there are cases where you just can't. So whether it be you need HIPAA or high trust compliance, those are ones that we don't have. We're working towards it. But if you have that kind of requirement, you're going to have to run on your own infrastructure. If you have a great price with your cloud vendor, again, you can't argue with that. If they've got a great deal, run with them. And then lastly, a lot of time, if you're trying to run outside of the big clouds, we can't, we don't do plug into your own data centers with our Aeon products. Only you can do that with the BYOC option. So we have a customer, Admiral, who's actually made a lot of different transitions over the time with where they're running their database. When they first came to us, they actually came and started using our OSS product. right out the gate. We helped them. We had a support contract with them, and we're helping them through all of their problems. And eventually they liked the software, and they realized there's another use case that they'd like to bring on that was going to be new for them, and they automatically put that on our fully managed Aeon products. We ran that there for about a year, and they realized, hey, why am I continuing to run this OSS product? They've already proven they can run it for me. It's been running great for a year. I'm going to move over there. So we actually had them move their OSS onto us. And again, take away all the responsibility for them to have to continue running the infrastructure in the database, and we put it on us. So now they have both their use cases running with us, and they haven't had any problems since. They haven't really seen the need to run OSS, and it's currently running, again, on our fully managed Aeon cluster. All right, so that's it for my section. I think we have about 5 minutes for Q&A if anyone has any questions.
Any questions, folks? I can run the mic. Aeon questions.
Yeah.
Oh, hold on.
Hold on.
Because we have
run
folks
the mic
joining virtually, so.
Suda's getting his exercise.
Here you go.
Hello.
Hi.
I have a few questions on replication. Specifically, when you're replicating across multi-regions, what kind of latency are you achieving?
So, great question. Yeah, so I don't know if everyone could hear that, but the question was,
Can you also introduce yourself very quickly?
I'm the chief architect from MasterCard. So, yeah.
Awesome, thank you. Yeah, so the question was, when you're doing a multi-region cluster, and there's kind of two different options, but what does the replication lag usually look like? How long does it usually take to catch up? To answer that question, usually it's the networking bandwidth that you have to deal with. If we're talking about AWS and we're going from, say, US East to West, I think that's roughly 60 to 7 milliseconds. And we're really at the mercy of that. And that's why when we talk about doing these kind of multi-region deployments, we really want to look at what are your latencies for your application require. If you need that really low level latency, but you have East Coast and West Coast, a lot of time that's where we say, hey, let's use that X cluster replication, because that way you have a cluster here and a cluster there, and you can feed your traffic into both sides, and you don't have to worry about the replication. There is the eventual consistency nature of it if you have a write coming in the same piece of data. So again, that really comes into what are the requirements behind the application. So yeah, it's just the general, what is the latencies between the two regions. Any other questions? Yeah.
Time for one more.
One more right here.
Oh, right in front.
I'm Uma. I'm a SA leader in Amazon Web Services, specialized in data and AI.
Okay.
I'm leading the strategic accounts. My question is you mentioned about Google Spanner too. So how do you compare this with the Google Spanner?
Great question. We actually take a lot of our inspiration from Spanner with some of the things that they do. Spanner is able to really hit high throughput. They're able to scale very well. I think one of the areas that they really struggle with is the proprietary nature of the API itself. When you go to something like Spanner, there are specific things that they do that is very different from the Postgres or MySQL community. So you sometimes get kind of vendor locked in to that. And so then making the migration from something like that to something that's more cloud native, and you can either run in GCP or AWS or Azure or on-prem, it makes that more difficult.
Besides proprietary, do you see any other aspects? I get the proprietary part of the storage side.
So there are a couple of things I'll just add to that, right? First of all, Postgres compatibility is a big thing. And for us, right from the get-go, Postgres compatibility was a big part of our story. I know Spanner has added Postgres compat in the last couple of years, but their approach kind of does not give you the Postgres compatibility that you really need. If you remember Karthik's presentation, he talked about runtime compatibility with Postgres. Turns out that if you really want the benefits of being compatible with Postgres, you have to pretty much reuse the code base, right? Similar to what Aurora does. But if you want that in a truly distributed system, there are only a few, Yugabyte is pretty much the option you have. Spanner, again, architecturally, Spanner was kind of the granddaddy of distributed databases in terms of how they architected the solution so awesome. It is something that inspired a lot of distributed SQL databases that came afterwards. But we kind of looked at what is it going to take to make that database more applicable and practical in terms of using it for your real-world applications. So for us, Postgres compatible, open source are all things that kind of feed into it, right? And in terms of architecture, it's closer to Spanner than to Aurora because it is truly distributed, sharded, shared nothing.
Cool. Anything else? Any other questions? Awesome. Well, thank you. I appreciate the questions.